Okay, welcome back to Secondary 2. Um, we are starting a brand new semester, right? We just finished up term 2, and hopefully you had a good Christmas break and were able to relax and have fun with your family, hopefully. Um, and hopefully you're kind of getting back into the swing of school a little bit, and getting ready to kind of survive the long haul that is, until we have a spring break in the spring. So generally this class is going to function pretty similar to what was going on before, right? Every day we're going to have like a homework, and a quiz that you're going to be doing at home, and it's still going to be structured in units like we've normally done it. So, but at the beginning here of this semester, what we're going to do is we're going to review a little bit of some things that you should know already, but hopefully this will just kind of help solidify in your mind these things so that you are ready for what's going to be coming later. And what we're going to be looking at today are what are called fractions, right? And I know you've seen fractions before. You should have done them in elementary school, and probably junior high as well. But that's what we're going to be looking at today. And fractions are of the form, right, when you have one number divided by another number. So for instance, 1 divided by 2 or something along those lines. This is what a fraction looks like, right? So we're going to just talk briefly about what do fractions mean, why are they useful, so that hopefully as you see fractions more in what we're doing this semester, you'll be kind of prepared to meet them head on, and be ready to deal with those, okay? So we're going to start by looking at, I have drawn here kind of a rectangle shape here, and I have pieces of that large rectangle. I have it kind of cut into, we have 3 this way and 4 this way, so 3 by 4 would give us 12 total pieces. So I've broken this one big rectangle up into 12 pieces, okay? And so I'm wondering here, what portion of this rectangle, what portion have I colored in blue? Okay, and so why fractions are useful is they help us represent, like when you have pieces of a larger whole. So we've got this one large rectangle here, and then we have it subdivided up into equal pieces, right? And so how much of our rectangle is blue? Well, notice there are 3 blue pieces, right, in this one large rectangle, right? And so we would say there are 3 blue ones, and then divide that by how many pieces are there total? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces, right? A 3 by 4 rectangle would give us 12 pieces, okay? So there's 12 in total. So 3 of them are blue, 12 total pieces, right? So how much of this rectangle is blue? Well, there's 3 out of the 12 that are blue. Okay, so this is how you would represent this in a fraction. Now, if you do remember, we can kind of make this fraction a little bit nicer, because 3 and 12 both share common factors, right? And you'll notice 3 goes into 12, right? So you could think of this as 3 over, well, how many times does 3 go into 12? It goes in 4 times, right? 12 is 3 times 4. And so when you have 3 divided by 3, those cancel, and we get 1 over 4, right? We could simplify that fraction a little bit, right? So this fraction is the same as this other fraction, right? 3/12 is the same as 1/4, okay? And we'll do some more simplification as we go along here, but fractions are ways that you can represent how much of a whole thing you've used, okay? Now, that's not the only way that you can represent pieces of a whole. You can also use decimals, okay? And so I'm going to show you decimals. And so if you take your calculator here and you actually do this division in the calculator, 3 divided by 12 or 1 divided by 4, you can actually get a decimal, okay? So I'm going to plug that in. I'll do 3 divided by 12 first, and I get 0.25. So as a decimal, so this is your fraction, right? As a decimal, what you get is 1 divided by 4 is the same as 0.25, okay? Or 25.25, okay? So that's our decimal. That's another way that you can represent parts of a whole, right? This isn't a number that's bigger than 1, right? It's a partial number, right? It's not a whole thing. You've got this is the 10th spot, right? So you've got 2 tenths and then 5 1/100ths. Okay, so that's our decimal. You could also do that just using the original fraction. Can't remember if I did 3/12 or 1 over 4 in my calculator. But if you do the other fraction, if I did 1 divided by 4, you get that same decimal. It doesn't matter, right? They're both equal. Okay. And last way that you could represent this is with a percentage. Okay. So a percentage, you can actually get that straight from the decimal. All you have to do is you have to move the decimal place over 2 places, okay? Because a percentage is out of 100. 100% is a whole. So 100 is 2 decimal places. So we're going to have, this would be 25%, okay? So there's a 25% chance if you took a square in this that it would be a blue one, okay? Let's go ahead and try the same thing with green now, just so that we make sure we kind of get this process down of what are the different ways we can represent parts of a whole. Well, you can do it with a fraction, you can do it with a decimal, or a percentage, okay? So let's look at green and see what our different fractions, decimals, and percentages are. Okay, so let's start with a fraction. How much of that rectangle is green? Well, notice there's one green box, right? So it's 1 divided by how many boxes in total are there? There are 12, so 1/12 is the fraction. Now notice that doesn't simplify at all because 1 and 12 don't share any common factors. So we can leave it like that. The decimal we get by plugging in 1 divided by 12 in the calculator. So we pull up our calculator and we do 1 divided by 12, which this says it's 0.0833, and it keeps going with threes forever. So sometimes we'll write a little bar on top when it's a repeated number there. Okay? So that's our decimal. And then the percentage, what we need to do is we just need to move that decimal point over 2 places. So we go over 1, over 2. So our percentage is going to be 8.3 with repeating threes percent. Okay, 8.3333%. Now all three of these things mean the exact same number. Okay, they mean the exact same portion of this rectangle. They're just different ways of representing the same thing, but they all represent parts of a whole, right? They're the same part of this rectangle whole. Okay, so you can see that fractions, decimals, and percentages are useful in us dealing with parts of things, right? You probably deal with fractions a lot when you're baking, right? You have quarter cups, half cups, and so on. And decimals you deal with a lot in science when you're measuring things with partial units on things. Percentages show up a lot in interest when you have money in the bank, or other situations as well. Population growth and stuff like that. These all show up. Also probability, which is what we're going to be going over soon. So you just kind of need to know, the different ways that you can represent parts of a whole. Okay, those are fractions, decimals, percentages. They all mean the same thing, but they look a little bit different. Okay, so let's go ahead and we're going to kind of focus the rest of this on fractions in particular, because those are usually the hardest ones for people to make sense of. Decimals and percentages aren't too bad to deal with. It's usually the fractions that throw people off. Okay, so that's what we're going to focus on now, is let's just look at fractions and make sure that we're really solid at messing around with them. Okay, so I'm going to pull up an example here. A few more. I'm going to have us look at how is it that we simplify fractions. Okay, so let's just do another example of that. So 21 divided by 48. If I had this fraction here, how would I simplify this so that it's a little bit nicer? Well, what you want to do is you want to figure out common factors between the 21 and the 48, right? So you can think of what sorts of things go into 21. Well, 21, let's see, 3 goes in there, and it's 3 times 7, right? Okay. And then I could ask myself, does 3 also go into 48, or does 7 go into 48? Well, to find that out, if I go in my calculator here, I'm going to do 48 divided by 3. Let's see what happens. Oh, I get 16. So this would be 3 times 16. It goes in evenly, so I'm going to write that down. Notice what happens when you do this. Well, you can cancel out the 3's, right? There's a 3 on top and bottom, so you can cancel them out. 3 divided by 3 is just 1. So this is the same thing as 7 over 16. Okay? Now, we could ask, can we simplify this any more? Well, does anything go into 7? Not really, just 1 and 7, right? Does anything go into 16? Well, like 2 goes into 16, 8 does, and 4 does, right? But none of those things also go into 7. So that means we're done. This is as simple as it can go. Okay? And then just to kind of get some practice with this, let's also convert these into percentages and decimals, okay? So let's start by converting it to a decimal just to see, make sure we can do that. So I'm going to divide 7 by 16. So we get, as a decimal, we get 0.4375. Okay, that's our decimal. These two are equal. Okay, and as a percentage, what I have to do is I just move that decimal place over 2 places. So a percentage, the way that you would write this as a percentage is 43.75%. Okay. Now, generally, on this, you would probably just leave it as a fraction at the end, but we're playing around with decimals and percentages today too, so we may as well just review that real fast. Okay, so that would be my decimal, that would be my percentage. Okay, so now that we've looked at simplifying fractions, let's look at what do you do when you're doing operations on fractions. So if you have a fraction, let's start with multiplication. So let's say I'm multiplying two fractions. 3/4 times 6/5. How do I multiply fractions? Well, what you do is you just multiply straight across. It's actually fairly easy. You just do this one times this one times this one. So you do 3 times 6 divided by 4 times 5. Okay, so you're going to get 18 over 20. Okay, now technically this is correct, right? This is the right answer, but we can simplify those a little bit. Sorry, there's a glare on that. I'm gonna try and adjust that light so that it's not quite so glary. Oh, that's not really helping, is it? Okay, there we go. Okay, so this is technically the right answer, but what we should do with this now is try and simplify it, right? So common factors between 18 and 20. Well, I know 2 goes into both of them. They're both even numbers, so let's start by simplifying that. 2 times 9 is 18. 2 times 10 is 20, so we can cancel out the 2's. So we get 9 over 10. Now, do we have any shared factors between 9 and 10? 9 has 3 that goes into it. 10 has 2 and 5. So, no shared factors there. This is as simple as it can go. Okay, so that would be our answer there when you're multiplying fractions. Okay, so multiplying fractions, you just go straight across. It's fairly simple, right? Hopefully you remember doing this. Dividing fractions is a little different. Let's try an example of that. So let's do like 2/5 divided by 4/7. Okay. So let's divide some fractions now so that you can see how you do that. Well, what you need to do is you use something that I like to call keep, change, flip. Okay, so you're going to keep this one. You're going to keep that 2/5 the same, but then the one that you're dividing by is going to get flipped. So you're going to change this to multiplication. You change it to multiplication and just flip the second fraction. Okay, So you flip that so it's upside down. Switch those two around. Okay? So that's how you divide, is you take the one you're dividing by, flip it, and then multiply. Okay? So again, how you multiply is just straight across. So you do 2 times 7 is 14. 5 times 4 is 20. Okay? And now this is technically the right answer, but I should try and simplify it, right? So what goes into 14 and 20 both? 14 has a factor of 2, so 2 times 7. 20 has a factor of 2, so we can cancel out those 2's, and we get 7 over 10. Okay? And then I could look, does 7 have any common factors with 10? Well, the only things that go into 7 are 1 and 7, and 7 doesn't go evenly into 10. So that's as simple as we could go on that fraction. Okay? So when you're dividing fractions, again, what you're doing is you keep the first one the same, you flip this one and change it to multiplication. Okay? Dividing is the same as multiplying by the reciprocal. Okay? So that is how you multiply and divide fractions. It's fairly simple there. Okay? Let's go ahead and look at, we also need to look at some examples of adding and subtracting fractions, which is a little bit difficult, a little bit more difficult than multiplying and dividing. So let's look at that now. Okay, so let's do an example here of 1/2 minus 1/3. So now we're going to be doing some subtraction. Okay, and this is a little bit more tricky. You may be tempted when you see like adding or subtracting between fractions to just subtract these two from each other, subtract these two from each other, just do straight across, kind of like what we did with multiplication. Okay, but that doesn't work because this is a half of a whole, right? This is a third of a whole, so it's like one piece out of 2 parts, 2 equal parts, and 1 piece out of 3 equal parts. Okay, so in order to be able to take these away from each other, they need to be out of the same number of parts. Okay, because it's like a 1/2. If I drew kind of a rectangle to visualize that, it would be 1 part out of this rectangle out of 2 equal pieces, and the 1/3 would be 1 piece out of 3 equal pieces, right? So I'm trying to take this amount away from this, right? So how I'm going to do that is I want to make a common denominator, okay? And that's what I'm going to do on both of them. I want them to be out of the same number of pieces, okay? So what I'm going to do is I want to try and get these two numbers to be the same. And how I'm going to do that is I'm going to times the top and the bottom by particular numbers to make them the same. So notice, what's a number that both 2 and 3 go into that I could make the denominator be? Well, 6, right? 2 times 3 is 6. So what I'm going to do here is I'm going to times the 1/2 here. I'm going to get there to be a 3 on the bottom. I'm going to times it by 3 over 3. Okay? Because when I times by 3 divided by 3, that's just 1, right? And so I didn't change anything in the fraction. And then on the other one, I'm going to times it by 2 over 2 so that I will get 6 in the denominator, right? 2 times 3 is 6. 3 times 2 is 6, right? So I'm going to have the same things on the denominator now. So let's go ahead and do that. 3 times 1 is 3. 3 times 2 is 6. Okay. 2 times 1 is 2. 2 times 3 is 6. Okay, so I've got a common denominator here. So what do I need to do? Well, now these are both out of the same total pieces, right? So it's like I took 3 parts out of 6 equal pieces. I took 2 parts out of 6 equal pieces. So I'm taking those away from each other. So I have 3. I'm taking away 2. So you just do 3 minus 2, still divided by 6. Okay, you don't change that at all. And you just get 1 over 6. Okay. So when you are subtracting fractions, your goal is to make the denominators the same so that then you just subtract the tops from each other. Okay? Let's try another example here. Let's do an addition example. So 3/5 plus 7/20. Okay? So again, your goal here, in order to add these, you need the denominators to be the same. You need them to be out of the same number. So you kind of think, with 5 and 20, how could you get those to be the same thing? Well, 5 goes into 20, right? And all I have to do to get it to be 20 is I need to times it by 4, right? So I'm also going to have to times the top by 4 to compensate. Okay? So what I'm going to do, I'm going to times the top here by 4. We get 12 over 20 plus 7 over 20. Notice now I've got the same denominator. I can add these together. We get 19 over 20. Okay? We just add the tops, leave the bottoms the same. Okay? So that's how you add fractions or subtract fractions. You make a common denominator and then add and subtract them. So I'm just going to go real fast through a few more examples to make sure that we've got those rules down, and then we'll be done. Okay? Oh, and I'm out of boards, so I'm going to have to erase some stuff. Okay, so let's just look at an example. We're going to start with, let's just remember, how do we multiply fractions? If I've got like 4/5 times 3/4, what do? You multiply straight across, right? So it's going to be 12 divided by 20 here. And now I could simplify that, right? We could think, what goes into 12? Well, 2 goes in there, 2 and 6, and 2 and 10 go into 20, so I could cancel out 2. So we've got 6 over 10. And then we should think, what common factors do 6 and 10 have? Well, 6 has 2 again, and 10 also has 2, so I can cancel those out. So I'm going to get 3/5 here. Okay, so when I simplify it, I get 3/5, right? But to multiply fractions, you're multiplying straight across. Okay? Dividing fractions. Let's do 5/7 divided by 2/9. Okay? In order to divide fractions, what you do is you keep this one, change this one to times, and flip the other one. Okay? So you flip this one and change it to times. Okay? So then you just multiply straight across. You get 5 times 9 is 45. 7 times 2 is 14. We could think about common factors. Well, 5 and 9 go into 45, but those don't go into 14 at all. Does 2 go into 45? No. Does 7 go into 45? No. So this is as simple as I can get. Okay, so that's how you divide. And then adding, what do we do again? For adding, we just make a common denominator, right? So let's do, we'll try this one. 3/8 plus 1/6. Okay, in order to add, you want to make a common denominator, right? So you want to think of numbers where of a number that both 6 and 8 go into. So can you think of a number that both 6 and 8 go into? Well, 36, I think, right? Or there might be a smaller one. Let's see, 6 goes into 12, but 8 doesn't go into it. And then 18, but 8 doesn't go into it. Let's see. Anyway, I think 36 would be a good option. So let's do, we're going to make the bottoms of them both 36. So I'm going to do 6 times 6 on that one. And on this one, to get 36, I'm going to need 4 and 4. Okay? So 4 times 3 is 12. And 4 times 8 is, wait, did I make a mistake? 4 times 8 is 32. Sorry. Okay, yeah, so that's a mistake, sorry. Yeah, so that's not going to work. So it doesn't go into 32. Let's see. 24, I think, has both of them. 4 times 6 is 24. And then 3 times 8 is also 24. So let's do those. We're going to make the same denominator on both of these, times this one by 3 over 3. This will give us 24. So we get 9 over 24 plus 4 times 1 is 4 divided by 24 is 13 over 24. Okay, just add the two tops together after we make a common denominator. Okay. Sorry about that on that last one. I was making some mistakes, but that's just how math is sometimes. Okay. So hopefully that makes sense. And you will be able to add and subtract fractions. This is something that there's a lot of YouTube videos for, so if you're concerned and need help, you can look up those. Thank you. I will see you guys in the next video.